In this video, we're going to learn how to solve problems involving repeated physics questions under the subtopic formation of images with plane, concave, and convex mirrors in reflection of light. So let's get started. The first one I have here says, where can a man place his face to get an enlarged image when using a concave mirror to shave? We have option A at the center of curvature, option B at the principal focus, option C between the principal focus and the pole, option D between the center of curvature and the principal focus. So the correct option to this question will be option C, which is between the principal focus and the pole. That's the correct option to this question. Alright, so let's go to the next repeated question. It says, where must an object be positioned in front of a concave mirror to produce a virtual image? Alright, so we have between the pole and focus, we have between focus and center of curvature, we have the center of curvature. So guys, the correct option to this question is option A, which is between the pole and focus. Okay, so that's it for this question. Let's go to the next repeated question, which is this one. It says, a boy on looking into a mirror observed that his face appeared to have grown bigger. The boy must have been looking at we have option A, concave mirror with his face between the focus and the mirror. Option B, convex mirror with his face between the focus and the mirror. Option C, we have convex mirror with his face at the focus. We have option D, concave mirror with his face at the focus. So the correct option to this question will be option A, which is concave mirror with his face between the focus and the mirror. That's the answer to this question. Let's go to the next repeated question, which is this one. It says, at what position will an object be placed in front of a concave mirror in order to obtain an image at infinity? We have option A at the principal focus, at the pole of the mirror, between the principal focus and the center of curvature, at the center of curvature. So the correct option to this question is option A, which is at the principal focus. Alright, so that's it for this question. Let's go to the next repeated question, which is this one. It says, the image of an object placed at 2 focal lengths from a concave mirror is what? So we have option A, real, diminished and inverted. Option B, real, magnified and inverted. We have C, virtual, same size and inverted. We have real, same size and inverted. So guys, the correct option to this question will be option D, which is it will be real, same size and inverted. Alright, so that's it for this question. Let's go to the next repeated question, which is this one. Okay, before I attempt this question, if you are new to our channel, ensure that you subscribe to this channel for more of our videos. Really appreciate this. So this question says, to produce an enlarged and erect image with a concave mirror, the object must be positioned at the principal focus. No, it's not correct. Between the principal focus and the center of curvature is not correct. Between the principal focus and the pole. Yeah, this option is correct. So option D says beyond the center of curvature. That's not correct. The correct option is option C, which is between the principal focus and the pole. Alright, so that's it for this question. Let's go to the next repeated question, which is this one. It says, an object 0 lies at a distance m in front of concave mirror of focal length f. If the m there stands for magnification, if the magnification is less than the focal length, then the final image of 10 will be, we have option A, magnified and erect. We have option B, to be virtual and diminished. We have option C, to be real and inverted. We have option D to be diminished and erect. Alright, so the correct option to this question will be option A, which is magnified and erect. Alright, so that's it for this question. The next repeated question will be this one. So it says, a real object is placed at a distance in front of a curved mirror of focal length. If the image is upright and magnified, then the mirror is, we have option A, convex, and object's distance equals the focal length, or option B, concave, and object distance equals 2 times the focal length, while option C, convex and object distance equals 2 times focal length, while option D, concave and object distance equals the focal length. Alright, so for the question, it said if the image is upright and magnified, so the correct option to this question will be option B, which is concave and image distance equals 2 times the focal length. Alright, so that's the correct option in this question. Take note of this particular question. So let's go to the next repeated question, which is this one. It says, when an object is placed very close to the pole of a concave mirror, the virtual image obtained is, we have enlarged and inverted, we have diminished and upright, we have enlarged and upright, we have diminished and inverted. So the correct option to this question will be C. So the correct option in this question will be option C. It will be enlarged and upright. Alright, so let's go to the next repeated question, which is this one. It says, an object is placed between the focal length and the center of curvature of a concave mirror. What is the type of image formed? So we have option A, we have virtual, upright and magnified, we have real, inverted and reduced, we have option C to be virtual, upright and reduced, we have option D to be real, inverted and magnified. So the correct option to this question will be option D, which is it will be real, inverted and magnified. So that's the correct option. Let's go to the next repeated question. Alright, so the next repeated question will be this question. It says the diagram above shows an object placed in front of a convex mirror. As the object is moved towards P, its image, which is located between P and F, will be what? So we have option A to be moves the right and becomes smaller. Option B, moves to the left and becomes smaller. Option C, moves to the left and becomes larger. Option D, moves to the right and becomes larger. So the correct option in this question is option C. It will move to the left and become larger. Alright, so that's it for this question. Take note of this particular one. So lastly, before we call it a video, let's look at this one. It says an object placed 10 cm from a concave mirror of focal length 5 cm would have its image. Option A, 10 cm from the focus. Option B, at the center of curvature. Option D, at infinity. Option C, at infinity. Option D, at the radius of curvature. So the correct option to this question will be option B, which is at the center of curvature. Alright, so this basically can deal with problems involving plane, curve, involving plane, convex and concave mirrors for your physics under reflection of light. So let's call the video, guys. Hope you learned something interesting from the video. If you are new to our channel once more, ensure that you have subscribed to this channel for more of our videos. Also like, share and comment on this video. Tell me how you feel for what I learned from this video. If you seem to have any specific question to ask regarding what I've talked about in this video, feel free to leave your question on the comment section below, and I will ensure to give you a response. Also ensure that you are part of our channel membership by clicking on the join button, where you'll be receiving special information that will help to simplify your academic work. Alright, so having known that, click on the end screen above and I will see you in the next video. Thanks for watching.